All right, so I think this is recording. Let's take a look here at this problem. We have this function 3x cubed plus 11x squared minus 6x. And really what this problem is all about is trying to factor this. But we don't have an x method. We don't have a technique really to help us with this x cubed at this point. But we do have kind of a hint here, a helpful start to it, that f evaluated at -4 is equal to 0. So let's look at what we're going to do. We've got this function f of x, and it's 3x cubed plus 11x squared minus 6x minus 8. So I want to factor this, and like I say, I really don't have anything at this point that will help me do that. I don't have a technique called an X method or anything like that. But with this -4, f of -4 equals 0 in factored form, that tells me that x plus 4 is a factor. And now the big question is how can I find a quadratic, an x squared plus x plus some constant, that when you multiply it times x plus 4, you get this original function. And that's where the synthetic division and this remainder theorem comes in to help us. Because this -4, let's make sure that our function is in standard form and that there's no missing power. So it goes 3, 2, 1 and a constant. So that's good. So we've got 3, 11, -6, and -8. So if this is a true statement, I'm expecting this to be a 0. What I want is these other numbers, because that's going to help me with factoring this. So the 3 comes down, and -4 times 3 is -12. Add those together and get -1. Now multiply that and get 4. Add those together and get -2. Multiply that and get 8. And hey, there's our 0. So this 3 helps me to say, hey, that's 3x squared minus 1x minus 2. So 3x squared minus x minus 2. Now, I have the skills to factor this. Now, maybe it factors and maybe it doesn't, but I can certainly tell you whether that's going to be the case here in just a second. Take the first term times the last term, and now we kind of have the game begins of trying to find two expressions that multiply together give us the top, but add together to give us the bottom. And I think that -3x and positive 2x do the trick. When you multiply those, you get the top. When you add, you get the bottom. Now, since the leading coefficient is not 1, I just can't come in and use the -3 and 2. I'm going to have to make a table, or some of you guys say chart it, whatever you call it. What I want to do is take this first term and this last term and put it along one diagonal, and the two numbers that I found in my x, put it along the other diagonal. It really doesn't matter which. I can interchange the information in the table and the diagonals, but I do want to keep them along a diagonal. So I look along here horizontally, and they just have that negative sign in common. These are both even numbers, so they have a 2. The 2 and 3 are prime, but they both have an x. And here I've got both of these that have a 3, and they both have an x vertically. So that helps me to now have this factored completely. I've got the x plus 4 that they gave me that information there, the f evaluated at -4 is equal to 0. And now I have factored this using the x method to get x minus 1 and 3x plus 2. So from here, if they want the zeros, I can set this equal to 0 and solve it. I can give the multiplicities of each 0. I can describe how it intersects the x-axis. From here, we've got a lot of tools to describe what the graph of this polynomial function is going to look like. All right, so I hope that helps, and I'll talk to you later. Bye.